Hello everybody. Today we're going to be going over integration by parts in Calculus 2. I'm going to teach you two different methods and you can choose which one you like the best. So, first, what is integration by parts? Integration by parts essentially says that the integral, of u times v hold on, let me erase this, is equal to uv minus the integral of v du. Okay? And a way to remember this is ultraviolet voodoo. UV, ultraviolet, V, do. Ultraviolet voodoo. It's quite interesting, actually. Which is why that's the thumbnail of this video, by the way. So, let's give an example. Let's say we want to find the integral of x squared sine of x. Okay, so let's designate a u and a v, or u and a dv. So how you would go about this is that your u is, you can choose either one. I'll choose x squared as my u, and my dv is equal to sine x. So this up here should be u dv. Okay. dv equals sine x. So to find du, we would have to just take the derivative on both sides, which is 2x dx. And then to find v on this side, we just take the integral. So v is equal to negative cosine x. The plus c is negligible. We don't need to worry. We don't need to worry about the plus c. Okay. So now all we do is we plug everything into our formula. So we get negative x squared. Here, let me actually start this a little bit higher up. We get negative x squared times cosine x. And then we're going to subtract the integral of v, which is negative cosine x, times 2x dx, which is our du. Okay. So it's looking a decent bit of it's looking a decent messy. We can in fact change these to addition signs right here, but I am not going to, because I will just do this again. So if we will do this again, let's designate for this integral specifically. For this integral, we're essentially gonna designate a u, and in this case our u can be 2x, and our dv can equal negative cosine x. Okay, and now let's evaluate our du. du is equal to 2 dx, and our v is equal to the integral, essentially the negative integral of cosine x, and the derivative of what? So the derivative of what is cosine? Sine, and then we just add the negative, so it's negative sine x. Okay. So now all we do is we chug this into the formula. So let's just simply go over and plug it into the formula. So u times v, which is negative 2x sine x. Can't forget our stuff over here. Negative x squared cosine x. And then now we want to subtract the integral of v du of negative sine x times 2 dx. Now we know how to do this. This is super simple stuff here. The integral of negative sine x is just the same thing as the integral. It's essentially cosine. It is cosine x. So we're essentially just going to change those signs, and the integral of sine x is negative cosine x. So we're just left with negative x squared cosine x minus 2x sine x plus, I meant minus probably fits, minus 2 cosine x plus c. And this is our answer for this problem. Okay. Now let's move on to the next example. Next, I'm going to show you the tabular method, essentially meaning that we're going to make a table instead of using this process. It may be a little more digestible and a little bit less confusing. So let's say we want to find the integral of ln x dx. So let's imagine that there's a little 1 here. We can make our little table, and what it says is that we have a d, I, and for our signs, we rotate signs. So plus, minus, and then it'll be plus, minus, and then it'll be plus, minus, down. But in this case, we only need 2 for this problem. So we choose one of these functions to derive. So I would choose ln x, because that's the more complicated. And then I would choose 1 to integrate, because that's super simple. So now let's just integrate 1 with respect to x. So that's x. Okay? And then now we just derive ln x, which is just 1 over x. Okay? And then the way to get this from this table is, what we're going to do is we're going to multiply down here. So x times ln x, which is equal to x ln x. Then what we're going to do is we're going to subtract this integral here. Subtract x times 1 over x dx. Now, this is the x and the x cancel, and we're just left with x ln x minus the integral of dx. So, in other words, this is equal to x ln x minus x. Can't forget the plus c. So in summary, you can use either your DI table, or you can use the traditional ultraviolet voodoo formula to evaluate the integral functions when two things are being multiplied or divided or combined together in some way. Anyway, hope you like this video, and I'll be taking video suggestions in the comments, so please leave your suggestions there, and goodbye.